Alright guys, in this video I'm going to show you how we add, subtract, multiply, and divide two functions. Alright, so the two functions that we're given are f is equal to 2x plus 1 and g is equal to 3x minus 2. So two linear functions. How do we go about adding, subtracting, multiplying, dividing those functions? And what is the domain of the resulting function? Alright, so to begin, we want f plus g. So we want f plus g of x. That is simply 2x plus 1 plus 3x minus 2. 3x minus 2. And that's it. This is f plus g of x. And so, combining my like terms, I have 2x plus 3x. That's 5x. 1 minus 2 is minus 1. And that is my resulting function. 5x minus 1. The domain of this resulting function is the domain of f and g. The domain of f and g, because these are two polynomials, linear functions, the domain of f and g is negative infinity to plus infinity. It's everything on the real number line. And so the resulting function f plus g of x, which is 5x minus 1, will also have the same domain. And so the domain is negative infinity to positive infinity. All right, so that's the first part done. Second part, we want the difference of the two functions, f minus g. Well, that will be, so we want f minus g of x. This is 2x plus 1 minus, parentheses, 3x minus 2. That parentheses reminds me that it's minus on everything after that parentheses. And so, distributing out my minus, I get minus 3x. A minus times minus 2 is plus 2. Combining my like terms, I have 2x and I have a negative 3x. Combining those, I get negative x. And I have 1 plus 2, that's plus 3. Okay, that's my answer. I just want the domain now, but the domain of the difference of two functions is the domain of the original two functions. So the domain of f and g again is negative infinity to positive infinity, and so the domain of f minus g will also be negative infinity to positive infinity. All right, so that's the sum, the difference. Now we want the product, f times g. So that's going to be 2x plus 1. 2x plus 1 times 3x minus 2. 3x minus 2. Product of my two functions. I have two linear binomials, so multiplying them out, I'm going to FOIL it. First, outer, inner, last. 2x times 3x is 6x squared. 2 times 3 is 6, x times x is x squared. 2x times negative 2 is negative 4x. 1 times 3x is plus 3x, and 1 times negative 2 is minus 2. Just bring my two terms here in the center together, combine them, I will get 6x squared minus 4x plus 3x is minus x minus 2. And so I end up with a quadratic, x squared quadratic trinomial, three terms. And so the domain of my quadratic trinomial, as with the sum and the difference, the domain is of f times g of x is simply all the values of x that are in the domain of f and g. That is everything on the number line, and so it is minus infinity to positive infinity. Everything on the real number line, to be specific. All right, and finally, I want the quotient f over g of x. And so I want f, this is part 4, I want f over g of x. And so that will give 2x plus 1 over 3x minus 2. 2x plus 1 over 3x minus 2. Usually at this point, I would check to make sure I don't have anything I can factor out above or below. Maybe it might cancel for me. I see that there's nothing I can factor out. And so I'm going to leave my answer in that form. And that's my answer, 2x plus 1 over 3x minus 2. So I'm left with a rational function. With regard to the domain here, it's a little different because I have to be careful with the denominator, 3x minus 2. Any value of x that would make my denominator, in this case 3x minus 2, 0, will not be in the domain. So I have to check to see if there are values of x that would do that. My suspicion is that there is. I will check by letting 3x minus 2 equal to 0. So we'll let 3x minus 2 equal to 0, and I will solve for it. 3x minus 2 is equal to 0, then 3x is equal to 2, and x is therefore equal to 2 over 3. So a value of x of 2/3 will make my function f over g of x undefined, because it will make the denominator 3x minus 2 equal to 0, and I can't have 0 in the denominator. So my domain then is going to be everything on the number line except for 2 over 3, 2/3. And I will write that by saying that my domain is negative infinity to 2 over 3, parentheses, soft parentheses, union 2 over 3 to infinity, soft parentheses. This soft parentheses, or soft bracket as I call it, it lets me know that 2 over 3 is not part of the domain. So the domain goes from negative infinity up to 2 over 3, 2/3, not including 2/3, and then from 2/3 to infinity. And that's it. That's our answer. We've combined the two functions in 4 different ways, adding, subtracting, multiplying, and dividing them, and we have found the domain in each case.